Now we're going to look at what is a GP. So let's consider the following sequence: 2, 4, 8, 16, so on and so forth. What do you observe in this sequence of numbers? I multiply by 2 to obtain the next term. Now let's consider a different sequence: half, 1/4, 1/8, 1/16, so on and so forth. What do you observe? I multiply by half to obtain the next term. So this leads me to define what is a geometric progression. It is a sequence of numbers such that the ratio between every pair of consecutive terms is a constant number. So let's write it out in a more generic way. If I define the first term to be A, and the ratio between every pair of consecutive numbers to be R, which means the second term will be written as AR. To obtain the third term, I multiply R again, I'll get AR squared. The fourth term is AR cubed, so on and so forth. So take note, this is the first term, this is the second term, third term, fourth term. So can we derive a generic formula by observing pattern for the nth term of the sequence? Very good. If I'm talking about the nth term, where is greater than or equals to 1, then we have ARn to the power of minus 1. So this leads me to deduce that for the nth term of a GP, AN can be written as ARn minus 1. N is greater than or equals to 1, where A is the first term and R is the common ratio. Now read the following 3 examples on your own.